So let's see. No. Okay, so are we back? No, we are not. Tell me we're back, please. No, I don't think we are back. Okay, so hopefully we are back. I don't know. Are we back or not? Yeah. Hopefully. Okay, yes. Looks like we are back. So, sorry guys, I don't know what's happening. CS mode, okay. Export path home/bin, and we're good. Yeah, cool. So now we installed everything that we might need, I think, and we can go ahead. Yeah, we are back, fortunately. And yeah, you are all too shy, so I removed the chat since it's not useful. And now let's see how it goes. Docker buildx build dot -t ghcr.io sosk and sosk 24. Okay, how do we call this? sosk 24 JLab v0.1 -- push. So someone yesterday or today, I don't remember, asked me, not to me, if we add GitHub container registry and if you can push the information directly to the registry without passing through ACI/CD, ACI actually, GitHub Actions in this case. And yes, the answer is yes. I don't know if I have the login now activated at the moment, but we are going to discover it very soon. So build, let's see. Okay, so it's downloading all the layers, and while it's building, I think we can take a look at what's happening. A KubeCon. So yeah, I agree. Argo, it's a really nice piece of software. Yeah, good job. A lot of streaming today, as is expectable. Yeah, let's change a bit of music. Cool, so it's downloading, it's doing all its stuff. Okay, so we take JupyterLab, TensorFlow Python 3.11, we install MLFlow and all the packages. What we miss is getting extensions. JupyterLab extensions helps people to work with JupyterLab as their IDE, and so it's quite important to give all the students a bit of introduction to what can be offered to them with a proper JupyterLab image. And in fact, git extension JupyterLab, we can start with JupyterLab git. Is this the one? I think so. Yes. Perfect. We can track all the changes. All right. So we need this as soon as we get started. So we are going to install JupyterLab git. So JupyterLab extension resources, CPU, memory, and whatever. So we just okay, so this is for the resources, system monitor, what it is, archived. Okay, so this is the other. Perfect. Yes, I need this. So again, JupyterLab. Okay, let's see. So you're installing everything, MLFlow, blah blah blah. Okay, so far so good. Then we insert this extension, JupyterLab Dask extension. Okay, so let's see if today we manage to do this one. And okay, now it's installing the minio client. Awesome. Again, let's take a deep breath and understand what we are doing. We have the JupyterHub instance ready, users log in, register, the administrator approve them, and when it's ready they can log in and use an image that we are preparing for them. The image is actually composed by a TensorFlow based JupyterLab image plus MLFlow plus some extensions plus MC client to access here the minio instance and the Dask instance. So we need Dask client, minio client, and other extensions plus MLFlow. That's all we need. MLFlow will save artifact on the minio server, so we have everything if we manage to publish this image. Alright, so this is exactly what I was expecting. We need to log in, and now I'll show you how. we need to log in into the GitHub container registry to be effective. But since we are here, I think we can start also adding some additional layer. Yeah, I'll add this in a separate layer. So let's install conda, install -y -c conda forge, and let's start with this. Well, JupyterLab I have already, JupyterLab git. Okay, then, oh right, isn't needed the Jupyter Hub packages? Let me check, because otherwise cannot communicate with the API of the app, right? Let me double check, just a second. No, maybe no. It was the case some time ago, not right now. Okay, good. Jupyter resource usages. So guys, if you have any suggestion for any other extension that you want and that you use currently in JupyterLab, drop a message. I'll add it right away. And then I had to understand if the Dust Club extension is needed or not. I think so. I think so. So call the JupyterLab and Node.js. Oh no, Node.js and the forge. Let's try this. Brace yourself. Okay. Bam. So MLFlow, we got it right away. Okay. Then we need also JupyterLab HTTP proxy. That will be the one responsible to forward the MLFlow server. So Python using Jupyter server proxy. Okay. Let's see the documentation. We need to exactly. We need to put something into the into what? Okay. Yeah, so this would be enough. Let's rebuild this and see if it's working. So you're installing this. Okay, this worked. Docker login. Ah, wait a minute. It's not the name of the repository. Come on. All right. Now we're talking. In fact, I had access to this repository that is the one for the school, and I am uploading the first version of our JupyterLab. So while this is pushing, I can already go here and tell my instance a few things. The first one is that the name of this guy v01, okay, it's this, and the tag is v01. Okay, so this will be CPU limit for each user. We have 30 users, 30 for 4 are under 20. Yeah, I think we can grant them. Well, let's be conservative, okay? Limit to 4, guarantee 2, memory guarantee 2 gigs up to 8 gigs. Cool. So this is gonna be really interesting. Okay. Then I want to node affinity. I would try to prefer it exactly. I want this. No, it's not node, it's pod affinity, sorry. I'll try to distribute evenly all the users that log in, so I avoid to populate one node more than another one. So prefer no. Pod affinity. Okay, I need to go back to this later, so if anyone connected knows how to spread, there was a way I remember I did once to spread pods evenly around the nodes, so no JupyterLab will end up in the same node if there is space on another node. But yeah, never mind. Let's see. Okay, we have our image available. We set it up here. We gave users some guarantee, and yes, so we are quite in a good shape. And yes, so we then need right, just a second, I'm trying to see if I'm missing something else. I think I had sync script. Yes, exactly. All right, then we need to create for each user, okay, their minio instance and their task cluster. But so far so good. Let's go ahead and apply these values. So we installed this JupyterLab with our brand new image, and yeah, just a drink of coffee, a bit of coffee, and then we can go ahead. Come on, what's happening? Okay, image pull back off because I can already imagine this. Yeah, be careful. Be careful every time you use the GitHub container registry. Unfortunately, by default, you will have private. You see here? So you need to go here, here, and change visibility public. Sosk 24 JLab. Oops. JLab. Good. Now everything should unlock pretty quickly. Maybe. Yeah, come on. Sosk 24 JLab B01 is public now. No? Ah. Packages. Okay. I see 8 pools, so B01. Okay. Now we are downloading. This hook image puller actually are the responsible to pre-pull the image for the JupyterLab into the nodes, right? So they are quite important because as soon the user arrives in this way, you will receive your information essentially. Yes. Okay, they are eventually completing slowly but steadily, so I can let this running. Okay, meanwhile, let's take a look at the KubeCon. A lot of fun. Yeah, kudos. It's really hard to translate technical jargon, I think. Hello, Steve Moss. How are you doing? Yeah. A lot of activities, yeah, all together. Let's see the Discover feed. Again, I can't get enough of this. Registering Blue Sky, it's a lot of fun, a lot of interactions, a lot of tech news, so yeah. You won't be disappointed, trust me. Inconsist with OEDC OAuth system. Pretty interesting. Okay, we'll take a look at this later. It's taking forever. Is this up and running? Okay. We are slowly completing. Slowly but steadily completing. I mean, this is good and this is also expected because we are applying an image that is quite big. Let's see how big it is. So it has to pre-pool all the image on all the nodes, and this image is actually, yeah, you see, 6 gigs. Not too bad. So it will take a while. So taking our block node, we have built this. We are going to take a look at how you can access MLFlow. We have installed Git, resource, Dask. I don't know what else we might have missed. If you have any other extension that you find useful when you do data science activities, yeah, just let me know. Extension is good. So there is a bonus item. I don't think we have in a good place to do this today, but if you are interested, we can schedule another streaming for Argo workflows. Yeah, I think we can go. The next stream can be very good for Argo workflow plus GitHubs. So we translate everything we did right now into something that is actually maintainable and operable. So we put a GitHub repository with all the need that manifest, and then we integrate this with Flux CD. So this continuous delivery, as soon as you commit something new, it will create changes in your cluster without you ever touching the cluster again. All right, cool. Brace yourself, guys. We are the moment of the truth. Okay, it's starting. That is already something. Let's see if the extensions have been loaded. So the resource one, yes, resources, we have resources available. We have also Git, initialize a repository, clone a repository. All right, good. We have task. We are creating. All right, workers. We have 4 processors, so we have 4 task workers. Yeah, pretty neat. Pretty neat. Love it. Love it. Okay, so everything is working. We only need to test one thing. That is MLflow serve. I never recall. MLflow, which is the name of the command. Just my MLflow minus help. Okay. Deployment, experiment, run. No. Server. MLflow server. So now, if I remember correctly, proxy, if I go the changot /proxy /5000, come on, almost there. Let me, maybe it's this minus address. We have to bind all the addresses. EP. Let me see. Come on. We are almost there. Everything is running. We miss, yeah, artifact destination. We put the S3 storage there. Host. Exactly. Come on. Why? Okay. We need to solve this. Let's see how we can tackle. So documentation says, if you have already a server running on localhost listening on a port, you can access it through the notebook at this and this. No, we need, okay. The host. User. Oops. We were so close, guys. So close. Git clone. Okay. Yeah, Git is definitely something that I suggest you to install. Let's see if someone had our very same issue. MLFlow JupyterLab HTTP proxy. Proxy 5000. There is something, unfortunately, you need to no. Yes. So, yeah, the thing. We are running MLFlow server on our host. I think there is something blocking from the ingress perspective, but let me check first. So, this is good. It's running, and something happens here, right? So the proxy responds with something. If I do this one, exactly. So someone is responding in here. There is some debug message that we can get. Maybe yes. MLFlow server unicorn debug. Guys, we were close. We were close. Okay, we might use this, but it's not the same. Yes. Yeah, this has to work. Oof. JupyterLab HTTP proxy, you need to install. No, it's not this. We also missed the music. Yeah. All right. I'm quite in the mood of closing this and be back to you with more news. But let me try one more thing. So, just to be clear, MLFlow server. Okay. Okay, artifact is good, it's good, secure tracking server versioning. For security reasons, you have to put host allow list. Let's see if we can make it automatic at the startup. Probably yes. So okay, read write JupyterLab in the containers. Nice extra pod config. Where is this? Yeah, but I don't know. Okay, so no, it's not even working. Why? So listening on the 5000. Okay. Is there any other browser here? Let me see. You see that MLFlow it is showing up here, but it cannot do it. Come on, come on. Then I promise we close here. We have our image available with all the packages that we need. So Dask cluster creation is enabled. We have Git repository. We have a possibility to show how much memory we are using. MLFlow is running, and we only miss the creation of the minio tenant, and some other bonuses. Yeah, are going GitHub, so will be for the next time. So I am close to shut down the episode here, but so I'm exposing 5000. It's working, but it's not showing the UI. I redirect to the correct URL for the particular user who is logged in. Wait a second. What is this? No, it doesn't. Yeah, no, it's not this. No, so it's redirected, but it's not that. Proxy absolute? I don't think so. No. No, guys. Only one hope. One hope. kubectl get pod -n cube system. Minus white. So I need ingress controller from the bastion. kubectl logs -tail 1000 -f -n cube system. Cube system. Okay. redirect proxy static main. Proxy static file. Okay, so we are missing more than something. Okay, it's not good, but it's something. It's not good, but it's something. All right. So let's try this. JupyterLab HTTP proxy missing JavaScript. We are closing to getting mad. MLFlow by any chance? No, this is not. No, MLFlow is not helping. What can help is this. No script. Maybe. Empty page. Okay. No. No. Don't tell me that. Holy cow. I don't know if you understood what just happened. We just lose 30 minutes ish to find out that, yeah, just a second, look, that this is not working. But this is working. I don't know if you understand how crazy it is. I'm almost mad. Holy cow. Okay, let's not lose any hope. Okay, we can go ahead and complete our task. So cool. Okay, so we have everything. If I do here import TensorFlow, okay, available CPU instruction perform the operation. Okay, and all the other stuff is in the import task. Yes, import 1 2 3. It's also good. And yeah, test really. All right. Okay. Then, sorry, was tired. Okay, good. Now what we miss? We miss just one thing. Yes, we miss the creation. I want to create a minio tenant for each user. How do I do this? How do I do this? Yeah, just 1 second, guys. I need to recall all the different steps. So okay. So what we can do is use a single tenant. Single tenant. No, I don't like it. So let's take our sketch here. Yeah, let's take our sketch, our tablet, and let's say that now we have our Jupyter. So we have our JLab here. Yes, our JLab. And inside this I have my MLFlow server. Good. Where I can store all my stuff. So I expose on the port 5000, and each user and each student will have its own MLFlow server. Then I want this MLFlow server to have the credentials to store the artifacts, models, machine learning models into an S3 bucket. Okay. So I think at this point we need, we can have a minio tenant for all the users, and simply create with an init pod. Okay, a pod running before the JupyterLab with all the credentials for minio admin, and it will do the add user plus create bucket. Okay, yeah. I think this sounds like a plan. And now we specify which kind of, oops, where is the, yeah, the values. So I will specify which kind of init container. I think init containers. No, this is for the hub. I need it for the single user, exactly. So toleration, extra node affinity. Oh, extra pod affinity preferred. This one. It's for spreading the pod, so we need to extra pod affinity preferred we are going to put, and then extra pod affinity network tools. No, events, extra notation, extra label, extra files, no. Init containers. So we are creating, we are attaching an init container to our spawning hub. Extra pod config, I don't know. Oh, maybe yes. We need our credentials. So extra pod affinity and containers. Yeah, sounds good. Sounds pretty damn good. So let's start again with taking notes for the next episode. So this still, come on, we got it. And now we have then to create init container with mc admin creds, create minio tenant, create user in minio tenant, and of course we need to create a minio tenant. Okay, and then we need set up cargo for the tenant. Create bucket, and also after that we need to point MLFlow server to minio for S3 artifacts. This can be a cool thing, showing them how to use an object storage, being just also an exercise, simple exercise, and it doesn't have to be too much complicated. The shared area, we need to understand we can survive with the local storage, so dedicating users, putting users to the nodes, or we want something more flexible. The problem that I have with being more flexible is that comes with a cost. So distributing file systems, if you do IO intensive task, you risk that the school is going into a disaster, right? Because 30 people start reading at high speed, and everything breaks. So yeah, I'll try to stay with the local path as much as possible. Let's see if we can avoid shared file system. I know it's not a cloud strongly cloud approach, but we have also to be practical. We cannot risk that something goes bad, yeah, very bad, just because we want to be cool and share file system and share the file system without having the actual hardware needed for 30 people, right? So it's this kind of balance. I put this inside brackets because again, Argo workflows in a 1 week school where people start from scratch, from knowing basic Python and being introduced to JupyterLab, different kind of technologies, MLFlow. With past experience, we know that it's hard to fit everything in there. So yeah, let's say humble if you want. What is instead very useful is having everything in one place, in one GitHub repository to manage all your deployments. So the Fluxcd deployment will be something that we are going to do next. Okay, so we did quite a lot, right? We did Kubernetes installation, operators, JupyterLab configured to do this. Let me see again. Okay, everything is working. I launch my MLFlow server and I can access the proxy service. Guys, I want to stress this. Remember, we lost 30 minutes behind this problem. The proxy wasn't working because you need to add a damn slash at the end. Voila. So big lessons learned today, okay? Maybe relearned. I have the doubt that I already faced this, but yeah. Periodically we discover new things that are old things. So okay, so and then we need to balance all the pod. Oh, right. Pod anti-affinity with preferred avoidance of JLab of multiple users on the same node. So we want to spread all the JupyterLab session around the cluster without ending up in the same cluster. So this is doable. I think it's affinity or anti-affinity. I mean, I'm sure it's anti-affinity, but I don't remember the actual extra pod anti-affinity. Yeah, exactly. Extra pod anti-affinity. And yes, I don't feel confident to guide, but if you have any question, I can take it and we can conclude like here, like that. So again, let me launch some music, and yeah, don't be shy. Drop a message also, just if it's to say hi, it's perfectly fine. Okay. So okay, we can set some label. Yeah, let's do this. Extra labels. Okay, we don't want to override this. We already done too much stupid things, too many stupid things. So JupyterLab true. JupyterLab true, and in anti-affinity preferred as a list we want what is that? Okay. Cool. So like this, right? Yes. Okay. Key JupyterLab. Okay. App JupyterLab. More meaningful. So app JupyterLab. Up in JupyterLab. Required during session or during execution. Preferred. Oops. Preferred extra pod anti-affinity, and in init container we go all the rest of our requirements. Okay. So let me do the upgrade. Let me see what happens when I upgrade. Cool. Okay. Perfect. Okay. And one last thing before leaving you guys, I think it's time. Keep ctr get node. So wide top node. So how many cars are this? Describe node. Allocatable. Okay, 16 core and 32 gigs of RAM. So we have 16 times 10 machine, and we need to divide by 30 or 40. Okay, so the limits are incredibly accurate, right? We put 4 CPU for 40 people. We will be 30, 35, so we are good. We are good, guys. All right. Yeah, awesome. So we need to understand, I think, if you want to somehow we can also include virtual nodes, since we are champion some virtual nodes with interlink and go to an HPC center spawning some cluster or some Dusk cluster or a JupyterLab instance, but for GPUs and so on and so forth. But for the school, for the sake of the school, I think we are good. We are good with just this list. So next time, oh, okay, this is done. So next time we'll end up everything. So what to say, guys? It was tricky, especially for the MLFlow proxy stuff, but we did it. We did it. It was a crazy nice evening, night, day, depending on where you are, and yeah, thank you for staying that long, and I saw people that stayed for a really long time, so yeah, thanks a lot, and have a nice day. See you next episode, where we are going to force ourselves to conclude this instantiation and then writing a blog about that. How does it sound? Sounds good? You want to say just last words? Otherwise, thank you and see you. Bye.